Hello, welcome to Latency Exchange. On this channel we discuss technical topics relating to low latency trading, concentrating on the exchange side concepts, technologies and processes. I'm Dave Beattie, a solutions architect specializing in low latency exchanges. In this first series of videos I will detail my architectural solution for a 24/7 low latency exchange. In this video we will look at the function and tuning of the gateway servers and how they support the connectivity requirements of the trading institutions. We will also touch on the subject of fairness, performance, and latency across this section of the environment. The gateway servers support connections from the trading institutions. They ensure that the instructions from the institutions are correctly formatted, in line with the exchange rules, and are within the trading limits for that institution. They take the requests from the institution and reformat them so that they may be passed directly on to the matching engine. As noted in a previous video, there are three principal options for the connectivity processes on a gateway server. Firstly, monolithic, where all participants connect to the same listeners on the same gateway servers. This is the simplest option, but is sorely limited in scalability. It also provides little in resilience between participants, allowing one participant to hog the access. The second option is to run separate listener processes for each participant on multi-access servers. In these cases, different server configurations could be used to provide different tiers of access. This would mean that institutions could pay a premium to use a server set that have faster processors with fewer listeners hosted on them. The final option is at the opposite end of the scale, where each participant is provided with a dedicated set of gateway servers. This obviously provides excellent separation between participants. However, the sheer number of servers required for even a modest environment means that this would very quickly encounter scalability issues. Optionally, listener processes could be pinned to CPU cores to ensure that they would never overrun the whole server, and they would never have to wait for a core to become available. It is likely that core pinning should be undertaken on all but the lowest tier of gateway servers. The final consideration for gateway servers is the selection of the protocol. Generally, the offered protocols fall into one of two categories: standard-based, such as FIX, or proprietary, with the former being slower due to the inclusion of a greater amount of functionality supporting a wider variety of situations. The main aim of the gateway servers is to provide equitable market access to all participants within a particular tier. In theory, the exchange would want to run as fast as possible in all areas, but this does not necessarily follow here. Studies have shown that if gateway servers run too quickly in comparison to the matching engines, they can cause a bottleneck, which raises a risk on the platform. Further, it can encourage unwanted behavior on the part of certain participants. These behaviors include trade or price sniping. It is preferable for the gateway servers and their surrounding infrastructure to run more slowly, but with a much greater degree of predictability of performance, i.e. fairness. This means that higher latency switching should be used in order to provide greater functionality. Such functionality is likely to be needed to support routed multicast with complex filtering, dynamic routing options with larger tables and complex filtering. Port mirroring might also be needed, although the use of passive optical taps is usually preferred. In most cases, consistent forwarding latency through the network is achieved with the use of single ASIC switches. Running all ports at one carrier rate ensures that consistency across the device is achieved. In the event that an exchange gets to such a size that single ASIC switches are not feasible, care must be taken to ensure that no unwarranted advantage is given to any one institution. This would typically mean that server-side ports should not be co-hosted on the same ASIC or line card as participant-facing ports. It should be noted that there are now some single ASIC switches on the market that have better forwarding latency on some ports than others. These obviously would cause a problem for low latency exchanges in relation to latency consistency. Once we have determined that the performance of this part of the environment does not have to be as fast as we can possibly make it, a fourth option for configuration of the gateway servers presents itself, that is containerization. For the most basic level of market access, containerized servers may be used as gateways. These would not benefit from the performance gains of a bare metal server, but are likely to be fast enough for some participants. Care must be taken not to propagate any performance loss into the low latency section of the core environment. When considering the failover requirements for the gateway servers, it needs to be broken down into two parts. The part of the servers that reside in the low latency network and face the matching engines participate in the standard four-way failover mechanisms for the core environment that have been previously described. The participant-facing side of the gateway servers needs to perform in a much more traditional manner. There are 4 servers separated into 2 pairs. Each pair is presented to the participants as a single logical host. This can be achieved using load balancer or clustering facilities. Each participant is provided with a limited number of logins on a specific port on each of the logical gateway servers. Servers within a pair maintain close synchronization so that the secondary may take over if the primary fails. Synchronization is also needed across the pairs to avoid duplication and to mitigate the situation where a WAN link or an access switch is lost. Ultimately, each pair of servers is serviced by a single WAN link in order to avoid shared fate scenarios. This means that if a WAN link does fail, the whole of the participants' trading must be carried out on the remaining logical server. In the next video, we'll cover the functions and performance tuning of the market data servers. Thanks for watching. Please leave any questions in the comments and I will reply to them as soon as I can.